is 2. In any case, we know that the velocity out there will be positive, which means that the particle is traveling to the right. So not only can we figure out that the particle changes direction at 2, we can say that it's going to the left, and then it changes directions and starts going to the right. Okay, be a little bit more specific about that. Now, if you want some graphical help understanding this, we can actually graph the original position function and get a sense for the actual motion by graphing this in parametric mode. So this is how you do that. Go back to, on your calculator, if you push the mode button, you want to go to par mode here. It's actually kind of fun to do. Okay, now remember this problem had to do with horizontal motion, left and right. Okay, we could have also done this with the vertical motion. But what I'm going to do here is the x is going to change and the y is going to remain the same, because we're not going to travel up and down at all. So I'm going to enter my displacement function, t squared, my position function. T squared minus 4t plus 3. And for my y, I'm just going to put in some constant. Like I'm going to put in the number 5. So that it'll just stay at 5. Now what I'm going to do is actually turn on the blinky spotlight here. Push enter until I get this plain old circle. And what it's going to do, it's going to show blinky but without connecting the dots. So what you're actually going to see when you graph this function is you're going to see blinky's actual path during that time interval. So let's say we do this for, I don't know, maybe the first 10 seconds. Okay. I'm going to set up my window. For time, I'll go 0 to 10. Okay. I'll do 0.1 for t step. And in my x range, now this is the range that we're going here. I'm not exactly sure what it's going to be. I know we started off at 3. We ended up going left for a while, then for 2 seconds, in fact. Then we went to the right. So I'm just going to put down maybe negative 5. I'll do the negative 10. And maybe for x max, I'll put 20. This is kind of guessing right now. You can play around with it a little bit. And I'll put 0 for the x scale. I don't need a scale. And for y, I'm just going to go 0 to 10, just so I can have that line at y equals 5 right in the middle. Now when I push graph, what you're going to see is you're going to see Blinky actually moving. And his speed is going to change as the velocity increases, and you'll see him change directions, just like you would if you were there watching it. Okay? So here's what you see. So you go to the left. There's t equals 2 where he stops and turns around and goes to the right. See how he's picking up speed the further time goes along. Okay. Now if you'd like to speed that up a little bit, you can actually decrease your t-step by changing that from 0.1, let's change it to like 0.2. It'll draw fewer points, so the whole thing will move a little faster. It's going a little slow for you. And depending on your calculator, memory and stuff, it might be a different speed. Okay? But that'll help you at least visualize, and you can check your answers that way too. Now if you're going to do the height, if you go back to the height model, what you'd have to do is you'd enter the function in for y, because that's what's changing, and you would put a constant in for x. Okay? That's a pretty cool way to check your answer and kind of see what's going on. All right, now that's a long one today. I've got one more example for you. I'll do this one in green because it has to do with economics. I know a lot of people, at least at this point, think you're going to major in something business, business marketing, things of that nature. What you might not know is that you actually are required to take calculus for a business degree, which if you guys get AP credit, then that's a class you won't have to take in business. But they actually use calculus quite a bit because they're into maximizing profits and finding optimal values based on information. So we're going to go through a very simple situation. Let's say we have a cost function. Let's call it c of x. So let's say this function represents the cost in dollars to produce x radiators. where x is somewhere between 8 and 10. Okay? And so let me write down those units. So C is in dollars, and X is the number of radiators. Okay. Now let's say we also have a revenue function. Now remember, cost means that's how much it costs the company to make that many radiators. So remember, we also said that X is going to be between, we have a restricted domain here, between 8 and 10. So the function actually is only valid for 8, 9, and 10. Since we're A's, we're not going to consider partial radiators. Okay, and let's say we also have a revenue function. A revenue is x cubed minus 3x squared plus 12x. Okay, now revenue is how much money we're going to make from selling X radiators. Okay, so again, R is going to be in dollars. 2. And X represents the same thing. So X is also the number of radiators, and it's between the interval from 0 to 10. So in business, the ultimate question is, how many radiators should we produce to optimize our profit? Okay, so sometimes we want to minimize costs, sometimes we want to maximize revenue, but sometimes there's this point in between where our profit is maximized. Okay? Now, profit is just income minus expenses, or revenue minus cost. Okay? So I could actually write a profit function here. So the profit function, we'll call it P of X. It's just going to be the R function minus the C function. Okay, so if I take R minus C, I'm just going to literally take R function, write it down, subtract the C function in parentheses, okay, now if I simplify things, x squared is going to, or x cubes are going to cancel out. We've got negative 3x squared, and this is going to be plus 6x squared. So that's going to be 3x squared. We've got plus 12x minus 15x, so it's going to be minus 3x. So that would be the profit function. Okay, so you can always create a profit function separately from the cost and revenue functions. Okay? Now there's a word in business called marginal. Like marginal cost, marginal revenue, marginal profit. Marginal basically implies rate of change. Or derivative. So marginal profit would be, what's the rate of change of your profit? Okay? So if you think about your profit graph, and you want to find the maximum profit, it happens right here. Well, what's going to be true about the slope of the graph at that point? What's going to be true about the rate of change of the graph at that point? It's going to be 0. So one way to optimize your profit is to find where is the marginal profit, derivative, equal to 0. And if you have functions for that, it's a pretty simple process. So let's say in this particular case, we're asked to find a few values. Like, what's the marginal cost? Well, the marginal cost is just going to be the derivative of cost with respect to x. So marginal cost is just going to be c prime of x. And going back to our original cost function, the derivative of this is going to be 3x squared minus 12x plus 15. Now the units would be units of cost per units of x. So cost units in this particular case were dollars. So the units here would be dollars per units of x, which remember was radiators. Okay. So the units on the marginal cost would be dollars per radiator.